Okay, perfect. So we're recording, and I want to start talking about Firebolt. This is a cloud-based database for big data, for terabytes. And then most of the time today, we'll spend on interview questions for data architecture. So about Firebolt. This is only on Amazon, but it can integrate with Power BI or Google Looker or any dashboarding solution, analytics solution. And this is quite unique database because it's about maybe 10 times faster than other big data warehouses, and at the same time 10 times cheaper. So if you look at this table here, you see examples of some queries, and you see for Snowflake, for example, at $16 an hour, and you have 60 seconds, and Firebolt is less than 1 second, right? Or 72 seconds, 100. So you see here the boosting, about 400 times faster, 800 times faster, 50 times, 6,000 times faster, and so on. So and they have similar improvements for other databases as well. So we may talk about Redshift or Athena or Google Query. Hold on. Yuri, mute yourself, please.
Sorry.
And so this is quite amazing. How they achieved that? How they achieved 10 times more performance at 10 times less cost. So I want to talk about that. There are only 2 slides in this presentation. So first of all, about the CEO of the company. He, before creating Firebolt, he created another company called Sisense. And it was, I think, in 2006. So now it's about 15 years in business. It has more than 800 employees. It's more than $1 billion evaluation. And Sisense is a dashboarding analytical, it's kind of like Power BI or Looker, right? You can connect to different data sources, and you can do graphics and analytics. And yeah, so he built a big successful business. And now he started Firebolt. About a year ago, they got their first, I think, about 30 million, and now they have maybe 130 million and 130 people, and the company is growing very fast, and it's advertising everywhere. So if you go and just Google for them, and maybe Google, not Google, but go on YouTube, they have a channel, they have a lot of presentations, demonstrations, explanations. It's quite exciting. They recently convinced Moshe Posumansky to join them. So he's a CTO of Firebolt, but a year ago, he was a principal engineer on BigQuery. I think on BigQuery, he was about 10 years. And before that, he was at Microsoft. He is the original developer of Microsoft OLAP cubes, the multidimensional cubes for analytics, and MDX. Multidimensional expressions, right? MDX. So he's a legend. And if you look at other people, so this is a quite unique company. It takes lots of years of experience in analytics and wizardry on how to make databases and achieve top performance. So here they made it, and they started from scratch. The database is completely SQL compliant, but it also has some extra types of indexes and their own proprietary file format, which allows them to achieve the speed. So let's go through the features. It beat performance of all major data warehouse providers by 10 or 100, while costing 10 times less. It uses Amazon S3 for storage. Eldad said in the interview that they can easily move, like port their system to other clouds as well, but they don't, they're not doing it right now simply because there's so much work at Amazon Cloud, which is the biggest one, and they have a lot of really big database installations who want to migrate from, let's say, from Snowflake to Firebolt. So they have their hands full. But they can do it in the future. So they're very fast. They only make sense when you have like terabytes of data, 1, 2, or 100 or petabytes of data. Then when Firebolt makes sense. So it runs a limitless amount of concurrent queries at sub-second performance at any scale. It has elastic architecture, decoupled storage and compute. So adding or scaling resources, it's really, really fast. So this is great, huge flexibility. Advanced data warehousing capabilities to manage ELT, storage, and concurrency without compromising the ease of use. Low cost, we already mentioned. So here's a good link. I highly recommend to watch it. So their main product person gives a short demonstration, and it's really exciting and convincing. So this is their main website, and some other links, right? Yeah, this is a stupid demo. They have a table with 42 billion rows, and they do query, and it runs less than 1 second. I will explain how things like that may be possible with this database. Okay, next slide, a little bit of explanation. So the main bottleneck working with S3 buckets is that usually the way people work with these buckets, they just read the whole file, right? And the same, for example, when you're using pandas data frame in Python, you just do pandas read CSV, right? So you read the whole file or the whole Parquet file. And similar people work when they're using Databricks, PySpark, they just read the whole file. And this is the bottleneck because S3 buckets or Azure storage, whatever, they're very slow. And what people at Firebolt decided to do, they decided to decrease the amount of reads. How they did it? Suppose you have an index, right? And when you have an index, then you can read only what you need, right? But the problem with that index becomes very big because it needs to contain information about every row, about every piece of data. So, and then where you keep the index, if you keep it again in the cloud, it will be a long time to read this index. So what they decided to do, they decided to kind of trim this index and don't go for the final piece of data, but go for ranges, right? So as you load data in the file format, which by the way is called F3, Firebolt file format. I guess S3 is a simple storage service. F3 is Firebolt file format. So as they put data in this file, they kind of split the data into ranges, and they populate the index, which only directs you where the ranges are. So for example, if you load data in one file and then in another file, you can use this index to tell, okay, if I need this value in this range, I can find it in this file in this place and in that file in that place. And then when you run the query, it runs in 2 steps. On the first step, you only read the ranges you need. So according to your where clause, you decide which ranges you need. And then you run the exact query from these ranges which you loaded into memory, right? So again, they have indexes in memory, and these indexes are small because they only keep information about ranges. And then after you load the ranges, you run the query on these ranges. Okay. So Firebolt avoids reading whole files. This is done by indexing data inside the files into ranges. This is called sparse indexing, right? The indexes are small, they're sparse, not very granular. Thus, indexes can be kept in memory and can help to quickly identify files and specific segments within those files which need to be loaded from disk to memory. Generally, they say that on average, they achieve improvements in this bottleneck, reading data. Instead of like reading like amount of data which Snowflake would read, they read only maybe 1% of that. So this is like a really huge increase of speed, simply because they don't read all the data. So API for Amazon S3 allows multi-part uploads, and also they have this method get object, and it has option range. So you can specify which bytes range you want to read. It's when you, like, for example, if you do regular file read and write, forget about cloud, just regular file system. There is a thing called random access, right? So this method, it kind of makes this functionality. So you can specify that you want to read from byte number 100 to byte number 200, for example. So additional indexes can be easily created for common aggregations and joins. Also for metadata like count, min, max, and strings. Now, about aggregations and joins. Think about OLAP cubes. The idea of creating multidimensional OLAP cubes was that you pre-calculate those aggregations at night so that next day people can just use them. They already pre-calculated. Here, they don't calculate aggregations, but they pre-index these aggregations so that you can calculate them much easier, right? And metadata. So for example, count one from table, right? And the table is 42 billion rows. Well, instead of doing this, you can just store this count somewhere and update as you load the data, and maybe minimum, maximum, and so on. And you can also do this for typical joins and so on. So a lot of queries become extremely fast simply because you pre-calculate this metadata. So they have aggregation indexes, they have join indexes, they have metadata indexes, and they have hash indexes for strings. So when you have two pieces of text, you have pre-calculated hashes, and you just compare hashes. Are they equal or not, right? Support equal or group by. So there is some trickery to make those queries faster. So these indexes improve performance by using cached pre-compute values similar to the idea of OLAP cubes. Right, I already said that. Further speed up from caching and reuse of compute subtrees and operators. Well, this is really under the hood trickery. And another thing that JSON is stored and processed natively using array functions and Lambda expressions. Some databases only allow to store JSON as a string, but here they actually store it natively, and the queries are fast because they don't need to parse the big JSON string. Okay, so data ingestion from all typical raw data format files, right? Okay, this is to expect. Oh, this is unique thing. They accept direct stream from Kafka. Sometimes when people say, well, we have real-time ingestion, what they actually mean is that first it goes from Kafka streaming into file, and then from file to database. But here they actually have direct connector from Kafka into the data warehouse. Ingested data is sorted, compressed, indexed, and materialized into Firebolt proprietary file format, F3 Firebolt file format. F3 benefits: sparse indexes, easy merging data for quick updates. Oh, okay, I haven't spoken about this. So when you think about that, you have two big trucks filled with what's called MMM, or the sweets, and they come in like red, yellow, blue, green. And suppose you want to merge them. So you want to put, let's say, two colors in one truck, two colors in another. It's very difficult to do because there are so many and you have to move each one individually. But if you first put them in ranges, so kind of think about bags. You have bag of red and bag of green. So all you need to do is to move those bags between the trucks. And this is the idea of, if you already split them into ranges, it's easy to merge between files. Sparse indexes, I already spoke about those, created automatically as you load the data. They're small, can be fully loaded in memory because they're small, and they help out to dramatically reduce input-output by pulling only small portions from S3 files, only the ones which are needed for queries. Granular data pruning allows to avoid fetching unnecessary data. This is just same thing which I already described. You put things in ranges. Cost-based query optimizer. Yeah, this is interesting. When you tune the query, you can optimize for minimum cost. So this is the interface. You need to look at it to see how it is done. Just-in-time compilation. Oh, this is really interesting. So what they do, they convert query basically into C code, and then they compile it in real time, and then they run it. So they use a low-level virtual machine to do that, and then once compiled, they can reuse it, or they can reuse part of it. Okay, Firebolt is built in C++, uses LLVM to dynamically and quickly optimize query plans prior to execution. CPU efficiency. Well, they know which computers they use. So they use the modern servers which have vectorized processing. In one click, they can do multiple operations in parallel, right? And they take advantage of this. So this is another speed up. And they use cache very creatively. Oh, okay. So what it all means is that these people know what they're doing. They created great product, and we definitely should look at it and maybe start using it with our clients. Okay, I want to stop sharing. Michael, take over. Now it's your part.
All right, so I'll share my screen. Let me know when you see it.
Yes, we see it.
All right. So me and Lev have been kind of going through different possible scenarios that are encountered during data architect interviews. And we decided to put together a document of the various possibilities. It's not finished yet. So that's why it says here, first draft, work in progress. I'm going to be reading two of the first sections if we get through both of them. So if you see anything that seems kind of maybe, wasn't perfectly formatted, excuse me for that. But also, as we go through this, I encourage you, and we talked about this with Lev, that if you feel like an answer is not adequate, please voice your opinion so that we could add maybe a correct or better version, so that we could kind of, hit two birds with one stone here. All right, so this section, I started kind of going through these.
Sorry, can you scroll through all the pages just to show the size of the document?
Sure.
Because it's more than 50 pages.
It's 50 some pages. And there's some sections that haven't really received much attention, but yeah. So there's quite a bit of different stuff. You could keep building this. We built this within, around a 4-week period so far, but it's definitely a lot of different information. As you know, data architecture is very broad, so there's a lot of stuff that is focused on. We kind of divided it into various sections.
Also, explain how you approached it, like where you took the original questions and like.
So, wait, can you repeat that? I'm sorry, I didn't hear you completely.
Okay, I just wanted people to hear how we started it, that we were searching for those questions online. We found many websites.
Right.
Discuss
so
the interview
we
questions.
did a very simple kind of approach to this. We got as many sources as possible within kind of a limit. Just maybe like a page full of links of various sources of architect-based questions for interviews. And we kind of went through it. And initially, obviously, everything was pretty much new. And then little by little, we started weeding out stuff that was repeating itself and adding sections that weren't there before. And some stuff emerged as being common. Other stuff it was more rare, but it was an interesting kind of look on how people view this stuff. What I could tell you is that there's a lot of different opinions about the role of a data architect. So I think that also matters if you're interviewing for a position like this. You could easily get somebody like these first two sections we're going to get through. You wouldn't really think of them as very tough questions, but in general, like most people would probably say a data architect is a pretty tough job. It's a nice pay level and a very, very huge knowledge base that it covers. But I literally have seen within the lists of questions, what is an inner join? So, and the thing is, at first you might think, okay, that just seems like an anomaly. But you know what? I know an actual person, a professional, who actually told me a very similar thing that they encountered in an interview. So you never know. That is why I don't think that all these questions, need to be super, complicated. They really don't. Sometimes you got to know that, there's going to be stuff in there that you maybe didn't expect. So I guess let's start here. This is just general, so there isn't any huge kind of category to lump them in. And I'll just start by kind of reading. And again, all the questions are not in this exact format. This was just the format that I encountered in some of the questions that I was viewing in the beginning, and I liked it, so I brought it into this document. So this one I labeled as pertaining to innovation. Have you ever taken part in improving a company's existing data architecture? Please describe your involvement in the process and the overall impact the changes have had on your company. And how to answer. So routine tasks and maintenance are an important part of the data architect's job. However, as a data architect, you should also be proactive and strive to improve the company's data processes and structures. Employers want to hire data architects with a critical mindset who are willing to take part in increasing the efficiency and productivity of current environments. So do your best to show the interviewer you don't get preoccupied with routine tasks and you don't lose sight of the bigger picture. I think the key word there is don't lose sight of the bigger picture. The architect has to view the bigger picture. So here's an example answer. In my work experience, marrying external data with internal data in corporate systems compose a variety of threats to data integrity. That's why I launched the project where I established a step-by-step screening process for our third-party purchase data. I also managed to further improve the relationship with our data supplier, who in turn agreed to run a few checks on their data before sending it to us. This initiative had a positive impact on the company's data reliability and decreased database errors by 29% within 1 year. One thing that I noticed there is he talks about how he communicates with various business professionals, and he also accomplishes a broader goal and brings improvements to the table. And I think that if you're interviewing for this job, they'll be looking for that sort of stuff. General security. As a data architect, have you faced any challenges related to the company's data security? How did you ensure that the integrity of the data was not compromised? So how to answer. Data security is a top priority for every company. That's why hiring managers would like to learn more about your experience with data security issues. When answering this question, emphasize that data security is an important aspect of your job, although your background isn't focused in that particular field. Again, you would probably have someone working with you on a team who was more familiar with the intricacies of data security, but as an architect, you would be managing their role on the team. When working in a team, it's sometimes hard to agree on what could pose a security risk. I remember a situation when some colleagues of mine wanted to change the established process for uploading franchise data to our system. I was sure these changes could result in security risks. So in order to validate my point, I calculated the possible financial loss to the company in case security was compromised. This prompted the team members to modify their plan to strengthen data security measures. So that's an interesting kind of way to get your point across. Just find a strategy that shows whatever they were trying to do might cost money or more money than is willing to be spent. So this I labeled as new trends/technologies. As a data architect, you should be up to date with the latest technologies and developments in the field. How do you keep yourself informed about the new trends in data architecture? When working in a technical role, it's common to get absorbed in the company's current processes and miss out on the latest industry developments. Hiring managers will value your willingness to educate yourself despite your busy schedule. So try to list news resources you're subscribed to and mention some conferences or trainings or industry events you attend when you have the chance. I do my best to stay informed about the latest industry trends and technology advancements. I believe this helps me learn things that can improve my work or inspire me to come up with an idea that will benefit the company's status quo. I'm subscribed to news feeds such as Information Week and Tech News World. I also attend 2 to 3 conferences a year where I network with other professionals in the field. Whenever my schedule allows it, I attend specialized trainings and seminars. Now, I just got a comment. I know that Lev is big on this one. Definitely keeping in touch with like kind of what's going on in the world and, subscribing to various different groups that are involved in the stuff that you're interested in just helps to broaden your perspective and sometimes gives you access to things that other people didn't even notice if they weren't doing that. And I think if you do want to have a role as a data architect, sometimes they're looking to you for new ways of doing things. So you showing that at an interview just kind of gives them the idea you might be that guy that would have a new approach. And here we go to the next one, general integrations. A lot of companies use data from both internal and external sources. Have you faced any problems while trying to integrate a new external data source into the existing company's infrastructures? How did you solve these problems? So how one would answer. External data often comes from sources using different data formats and systems. Obviously, that may cause a series of issues when importing this data into the company's data systems. As a data architect, you have to make sure the data format is readable and ready to use before storing it in any data warehouse. With this question, hiring managers want to assess your problem-solving skills when faced with external data integration challenges. So try to provide an answer that will demonstrate how you address such an issue. And this is very accurate. When I first started at Redapt, I was talking to a data architect working here, and he specifically told me about how they had interviewed someone and posed this exact question to him. And he said, well, he hasn't ever had to deal with that because he's dealt with stuff like that was pretty much already familiar, he was familiar with. So this seems like an important point. And here's an example answer. In my work experience, the cause for external data integrations issues is usually a different system that creates the data in an incompatible format. Unfortunately, it isn't possible for all companies to use the same systems. So I solved this problem by creating and running a script prior to uploading the data in my company's warehouse tables. The script only changed the external data format, but also ran tests to ensure the new format was compatible with our systems. Let's go here. This is just very general. What is a data architect? Please explain. The individual who is into the data architect role is a person who can be considered a data architect practitioner. So when it comes to data architecture, it includes the following stages: designing, creating, deploying, and managing. All these activities are carried out with the organization's data architecture. With their help and skill set, the organization can make constructive decisions of how the data is stored, how the data is consumed, and how the data is integrated into different IT systems. In a sense, this process is closely aligned with business architecture because they should be aware of this process so that the security policies are also taken into consideration. And this seems like kind of like, why would they ask that? But they could ask you like, so like, what exactly is a data architect? What do you see yourself applying for, basically? Like you have to kind of step out there and say, well, this is what I would be doing for you guys. Now this answer is very general and is one option, I think, but you could kind of get creative here. And if you have some special abilities that you perceive as being able to offer on the table, it's your chance to put those in there. And let's go to number 6. What are the fundamental skills of a data architect? The fundamental skills are as follows. The individual should possess knowledge about data modeling in detail, physical data modeling concepts, should be familiar with ETL process, Should also be familiar with data warehouse concepts, hands-on experience with data warehouse tools and different software. Should have experience in terms of developing data strategies, build data policies and plans for executions. Again, kind of an obvious one, I would say. So here's a little bit more of a technical one. Differentiate between OLTP and OLAP. So OLTP or OLAP. OLTP stands for Online Transaction Processing. OLTP is known for maintaining transactional level data of the organization, and generally they're highly normalized. It is, if it's an OLTP route, then it is going to be a star schema design. And OLAP stands for Online Analytical Processing. And this is for, to do with analysis and fulfills reporting processes. It is denormalized. And if it's OLAP, then it will be a snowflake schema design. And this is where I kind of wanted to involve the group. Is that definitively so, where it's always this way? Where if it's like OLTP, then it would be a star schema, and OLAP, it would be a snowflake schema? Or is that just, is he just kind of making generalizations?
Oh, Tyler, can you?
Yeah, from my experience, I would say OLTP actually would probably not even be so much a star schema as more a little bit more normalized.
Okay, so you're saying that like when it's normalized, it's not going to be a star schema,
right? Yeah. So
okay.
The star schema, typically it's more of a flattened structure in the database, just so that there are fewer joins to do to make it easier to write queries for reporting and that sort of thing. With OLTP, I would say that's more, for like transactional systems. So, a point of sale system, for instance, or the back end for an ERP system, or, things like that. And so typically it'll be more normalized, where you have each type of entity would have its own.
Would you say then
table.
maybe the best way to cut this answer would be just to keep this first sentence?
Yes, I would say so. Yeah.
Yeah. Because I was wondering about that too. It didn't make much sense to me, and so good thing you chimed in. And this one is, you feel like is accurate here?
So I'd say the first part where it's denormalized is accurate, and then Snowflake and star schema are pretty similar to one another. So I think typically you'd probably try and design your OLAP system with a star schema if possible, just to keep it as simple as possible.
Gotcha. Stars, okay.
Yeah.
Star schema.
I would say a star schema for OLAP is generally going to be preferable, but sometimes the complexity of the data requires a Snowflake schema.
Gotcha. Perfect. All right. Thank you.
Misha,